Good morning, colleague. Hey! Today we are going to solve exercise 3.14 from the book Fundamentals of Electrical Circuits by 6. In this exercise we are asked to determine the sub-zero voltage using nodal analysis. Voltage is a being that is demarcated in the resistance of 4 ohms. As always, we do a little visual analysis, looking for a common sense for the direction of the currents, and then, we will pose the equations. For example, I remember that in this 40-volt source I observed that the polarity goes upwards. So, as I see that the polarity is going to be the force exerted on the current that is upward, when it reaches this node, this node is going to be called V1. The current has to take direction somewhere. Once this is the amperes that tells me that the current is going there, and the other time I assume that it could be in this direction. Remember that this is everyone's consideration. Others may say it goes in the other direction. It doesn't matter, right? The result is the same. In this node I'm going to call V sub 0. I call it 0 because it's the resistor 4 node. By the time we calculate it once and for all, it will be what the book is asking us for. When it gets here we see that the current is 5 amperes and the current that comes from here reaches this point, because it has to take directions. The first direction that comes to mind is downwards. It comes to me for 2 reasons. 1, because at this point the tension is my reference, it could be my zero tension. And the other reason is because the polarity of the resistor is more minus. This is the main reason why it polarizes more minus the direction of the current, and I assume that it is towards here, in the direction of the voltage source, and it makes me a force. It's her. I guess it's coming this way. Okay. Now, what I'm going to do is an analysis first in V1, in the V1 node. I am going to look at the currents that enter the node and that they will be equal to the currents that leave the node. The currents that enter through this node, I'm going to name the currents. You are in I1, you are in I2, and this is going to be I3, and this is going to be I4, I1 in that direction. Therefore I say that it is 40 minus the voltage 1 yes over 1. We see that another 40 enter this node. We see that nothing else enters this node. This is going to be equal to the current I2 and the 5 amps plus the current I2, but the current I2 is equal to V1 minus V sub 0 over. Well, it's going to be higher. 5 amps plus V1 over 2. This is the current I2. Okay. Now, I applied algebra here. I have that 40 minus V1 is going to be equal to 5 plus V1 over 2 minus V sub 0 over 2. I have to leave the variables aside. So I'm going to pass this variable over there, and this value, this constant, over there. So doing that operation I'm going to get V1 plus V1 over 2 minus is 0 over 2. It's going to be equal to 240 to 5. So V1 plus 1/2 of V1. This is going to be equal to 3/2 V1 minus 0 over the 40 to 100. Well, I can eliminate the denominator by multiplying everything by 2. I will have 3 V1 minus V sub 0 equal to 70. This is our equation. I'm going to put it here. Same 70. Okay, now I'm going to work with 0 on node 0. The node. We see the currents entering 0. The first is the plus current source. The second is the current N2, and that is going to be equal to the currents that come out. So I have the current N3 and the current N4, so the current N2 is 5. The current N2 is the current that comes from here, which is V1 minus V0. All this about the 2 min, which is going to be equal to 43. The current N3 is going to be V sub 0 over 4 ohms plus the current N4, which is V sub 0 plus 20, because more V sub 0 generates a voltage to the right, and this voltage source confirmed it for me. It corroborates it for me when I see that it pulls the current towards that same direction. All this is about 8. I apply. I'm going to have 5 amps plus 1 over 2 minus 0 over 2 equals 0 over 4 plus sub 0 over 8 plus 20 over 8. Well, I'm still trading. I will leave. I'm going to pass all this over there. And the constant over there. So I'm going to have V1 over 2. Hey? Less than 2. Minus 0 out of 4 minus 0 out of 8. It's going to be equal to about 8 minus 5. Okay. V1 over 2. We don't see that there are any variables. A minus 1 middle minus 1/4 minus 1/8. That gives me, it's going to give me minus 7/8 dB sub 0 equal to 20 over 8 minus 5 is going to give me minus 5 minus, I'm going to multiply by 8. I'm done here. And it's going to look like V1. For 8 it would be 4 volts 1 minus 7 minus 0 is going to be equal to 8, and 2 would be 4 20 less. This here would be my equation 2, which would be 4V1 minus 7 V sub 0 equal to minus 20 would be my equation 2. These two. They are the ones that I am going to enter in minus 3, minus 1 and 4 and minus 7. Well, I put minus 3 space minus 1, semi. It says 3 minus 1 and 4 minus 7 is 3 minus 1 semicolon 4 space minus 7 and close. Now, the result of the matrix will be 70 to 20. 70. 20. Ready? Hey, I start the program and the solution will be A versus B, except that the matrix A is 3 minus 1 and 4 minus 7, 3 minus 1 and 4 minus 7, and the matrix B is 70 and minus 20. This result tells me that B1 is equal to 30 volts and B2 is equal to 20. B it is equal to 30 volts and B2 is equal to. Those are the tensions that he asks of us. The exercise we have to identify now the voltage B1 is in B2. This is D sub 0. I called it sub 0 if B1 and B sub 0 and this time sub 0. This is what the exercise that you have seen is asking us for. The voltage on this resistor. Well colleagues, until the next exercise.